Good morning, Year 7 mathematicians. I'll say good morning in front of the camera. Hello, how is everybody? And I hope you're all working away on your Pythagoras projects. This is my office, there's my library, some chairs piled up in the corner there, my computer, and on my desk I've got this box. And I'd like you all to find a box, something like this, and take some measurements of it. So let's have a look at this thing. And the box has a width or length of 34 centimeters. Let's get a bit of paper and write that down. Oops. A length of 34 centimeters. A width of 18.5 centimeters. If I'm going to do it to the nearest tenth of a centimetre, I ought to measure it properly. It's 34.2 centimetres is the length, width of 18.5, and height. I have to get down here to measure the height with this ruler. A height of 12.2 centimetres. 12.2 centimetres. So I hope you can see all of that. Those are the measurements I took of my box, and I'd like you to do similar measurements with your box. The question which I now have is, what is the longest long thin object which will fit inside the box, completely inside without sticking out? And that means we have to go on the longest diagonal of the box, and the longest diagonal of the box is from this corner down here, the furthest away from me, lowest, and on the left hand side, right the way up to this corner here, which is the closest to me in front, on the right hand side at the top. And that's the longest diagonal of the box. And the question I have is, let's find a long thin object that might go there. Here we are, here's a long thin object that just about fits inside the box. The box will take an object that's just a little bit longer than this knitting needle. But how long is that? And how do you find it out using Pythagoras and the measurements of the box? I'm not going to tell you what my box measures across the diagonal, and I'd like you to do that for yourselves. Find some sort of box. It could be a big one or a small one. Look, there's a box over there with something in it, or it could be something quite small like a matchbox, or here's a different box here, a box which I keep my ink in for my pen. Okay, you could do a similar thing with a box like that. Okay. Take the measurement of the width, the height, the depth from back to front, and then see if you can work out what is the length of the longest diagonal inside the box. If I come back to this one here, the longest diagonal would be the place there where this pencil is resting. From closest towards me, whoops, not resting very well, but you can see the idea. What's the longest diagonal inside that box? And how does that relate to the width, the height, and the depth of the box? And that involves Pythagoras, and I would like to see if you can do that. And I will put on the classroom a problem for you to solve with a box with given sizes. I am looking forward still to getting your projects on Pythagoras, which I've received from about half the class. The other half, you need to accelerate the work and get something to me. So I look forward to that. So thank you very much, and I will post this and other things up on the Google Classroom. Goodbye for now.